Welcome back. In this lesson, we're going to look at severe storms. So a storm, of course, is air that's disturbed because of heat and water. And this instability or this unstable air can actually be made worse by the storm. So a storm can be self-perpetuating. In rare cases, you can have very, very large storms. So we're going to look at these storms, what they caused or cause. We're going to look at hail and how hail is formed, and also tornadoes. So these wind events that's caused by the different temperature events inside serious thunderstorms. So let's look at some examples. So a thunderstorm, by nature, is unstable air. You've got air rising very quickly. You've got air sinking very quickly. You've got tumultuous winds inside a thunderstorm. You've got these clouds can make lightning that hits the ground, and it can also have lightning that hits within itself. So you can have like sheet lightning where it's inside the cloud. That's actually one lightning bolt from one side of the cloud to another. All this instability can actually make a thunderstorm worse. It can actually grow on itself. When you have a severe thunderstorm, these things can keep energizing themselves as long as you've got hot air and cold air. And once you've got this these churning winds, you can actually make it big. It gets bigger just by itself. Okay, so the more instability in the air, the more instability will be there because of what's happening inside the cloud. As a result, these can be enormous storms. So you can have very, very large thunderstorms. These thunderstorms are called supercells. And they, of course, have ridiculous amounts of precipitation and serious winds. And many of these are the ones that would be responsible for hail. So if you think of when you would have seen hail, it's normally not in the wintertime. Hail is usually in the summertime, where you have hot, moist air that's being driven high up into the atmosphere, and once it cools off, it condenses. When it condenses, you're going to get winds, and then as you get these winds, any precipitation that falls inside the cloud, if it's very, very cold, it can turn into ice. So you'll have little raindrops that turn into ice. Well, the winds are so furious inside certain of these supercells that will drive the raindrop that's now frozen up to the top of the cloud again, and it'll fall again. And as it falls through all this moisture, more moisture sticks to it, and you end up with ice balls. Some of them small, some of them the size of grapefruit. So a lot of this is because of just the enormity of the amount of moisture and the temperature difference between the rising air and the cold air that it's rising into. So consequently, it doesn't happen very often. You really have to have lots of different parts for this to become a monster. But monster storms are possible. You can conceive of a monster storm being possible. So 240 kilometers per hour is about 150 miles an hour. So you can have downdrafts and updrafts that heavy. So you can imagine flying an airplane in something like that. So if you were to have a downdraft, say, here's an awful picture of an airplane trying to land on a runway with a downdraft coming from a thunderstorm. How do you do that? I just hope he has some experience. So the downburst depends on how big of an area. If you have just a very small place where you have a serious wind that's coming straight out of a thundercloud, that's called a microburst. A macroburst would be a bigger wind coming to a bigger area. So I already mentioned hail. So you've got freezing pellets of ice, and then those ice pellets are light enough because the wind is so severe to not just fall from the cloud, but actually be swept back up to the top of the cloud and then gets to fall again. And you can think that the stronger the wind, the more often that these little balls of ice get to go to the top again. Every time that it gets a ride, it's coated in new water. And of course, that water immediately freezes because of the temperature of the air and the ice that it's sticking to. And so it gets bigger and bigger and bigger. So you can get ridiculously big ice balls called hail. Now a tornado is very rare, and you're going to see that there's a tornado season. So there's tornadoes in the United States every year, but it really takes a lot of parts for a tornado to form. Okay, so if you've ever let the water out of your bathtub and you get a little tornado as the water's going down the drain, certain things had to happen for that to happen. You needed a low pressure, and you needed moving water to create that low pressure, and then you end up with that kind of funnel-shaped vortex. A tornado starts when you have high winds in the upper air and low winds towards the ground. So look at picture A. If you can get high winds up high, going in the same direction, by the way, they have to be going in the same direction, but one is going faster. The upper one is going faster, the bottom one is going slower. I suppose it's possible that you could do it backwards, but normally you're always going to have faster winds up high and slower winds along the surface of the ground, because it actually drags on the ground. There's friction on the ground as the wind is blowing across trees and mountains, etc. So usually it's high speeds, low speeds, and what happens is that the air starts getting a turn in it because it's lopsided. You're having fast on one side, slow on the other side, so you end up with eddies of turning air. And if you can keep that going, okay, it has to be perfect conditions. If you can keep that going long enough, and then get a good downdraft from that thunderstorm, it will actually take the tail of that cloud and put it down. So you can get almost tornadoes, okay? So an almost tornado can form in the air, but if it doesn't actually touch down, it's not considered a tornado. So you can have 99% of a tornado, but the damage is done when you have that low pressure. And by the way, that's what a vacuum cleaner is doing. Vacuum cleaner is low pressure. So low pressure riding along the edge of the ground is sucking everything up into it, and whether it's a cow or a car, it'll go up into the cloud. That's pretty scary. Tornadoes are classified by the Fujita scale, which is I suppose Japanese. I should probably have known that. In any case, it's essentially like the hurricanes where you have wind speeds. And if you have certain wind speeds, it's classified as an F something. And the Fujita is the F. So you have an F5 tornado is ridiculous, 300 miles an hour winds. That's really amazing. Most tornadoes don't get over 200 miles an hour. So 150 miles an hour tornado is a strong tornado. That's an F2 tornado. But there are more damaging tornadoes. Of course, if you have the conditions, you could end up with a perfect storm for tornadoes. Now the enhanced scale has to do with damage. Not exactly how much the winds are, but what the damage is being done based upon the winds. And so there's actually a couple different ways you can do that. Most tornadoes don't form when the air can't get around objects. So in mountains, it's rarish, pretty rare for a tornado to form, because you've got to get winds that are going fast in the top, slower along the bottom in the same direction. And when you have mountains, normally the winds are blowing around the hills. You can't get that turn that you would need. Also, if you did have a tornado and it runs into a mountain, it basically just tuckers out and you don't have a very long lasting tornado. So the Tornado Alley is in the Midwest. This is in the flatland in Nebraska, Kansas. This is where Oklahoma, oh my goodness, Dorothy, is not in Kansas anymore. So that you have these serious flat land with hot summer days to where you have these abilities to form thunderclouds. And so you essentially need a thundercloud in the sky at the same time as low-level winds that are slower, and then you can end up with a tornado. People who live in the Midwest have tornado drills all the time. every school kid will practice tornado drills, and most schools and colleges will have some place to go in the event of a tornado. So there's shelters and there are basements and things like that that you would go to. And of course, if you're worried that the roof is going to be ripped off, you'd want to go to the inside hallway or maybe inside the bathtub, so that if the roof does come off the house and all of that pressure is sucking into the roof, then you would at least be as protected as you could, because one side of the house won't fall on you if you're protected that way. Boy, these are scary lessons. Sorry about that.